A few minutes to always technical problems. That's what the technology made for. And we are very pleased today to have Professor Mehdi Elahi from the University of Bergen to join us today for our HVL Data Science AI seminar series. And just I'm telling a few words about his background, and then we start with his nice presentation. So, Professor Elahi is an associate professor at the University of Bergen, and he got his Ph.D. in computer science and has a long list of publications in this field. And his work so far got a very good attention and citation. And his research interests primarily focus on AI and data analytics, with emphasis on these recommendation systems. And also, he is a co-inventor and owner of US patents in these fields. And he is also involved in different European, international, and Norwegian projects related to the recommendation systems and AI. So, yeah. And I can say that he's also very active in working with the companies like Amazon and IBM and amongst others. And thank you for joining us today, Mehdi. We are looking forward to hear about your interesting topic in the recommendation system. The floor is yours. Thank you.
Thank you very much. Hi everyone, those attending in person and those online. Thank you, Dr. Reza, for introducing me. As he mentioned, my name is Mehdi Elahi. I'm an associate professor at the University of Bergen. And my main research topic is recommended systems since 15 years ago, maybe even more. And today I'm going to have a brief lecture on what are these systems, basically from the data point of view and methods point of view. A little bit about myself. You already mentioned I have actually background in electrical engineering. I got my master's on that. And I got Ph.D. in computer science from Italy, and then became assistant professor and associate professor later. Since I joined basically University of Bergen, I've got this associate professorship position. I have been working or been educated in different institutes. Before coming to Norway, I had been in University of Bolzano, which is in north of Italy. That's a small university, but highly ranked due to several, let's say, great researchers and good performance. And you can see that it's located really on northwest part of Italy. And I also did my postdoc in Politecnico di Milano, or Politecnico University of Milan, and great experience. And then I joined University of Bergen, where I co-founded together with our colleagues a research group called DARS, which basically stands for Data Analytics and Recommended Systems, which is focused on this basically research topic in Norway and also collaborating in other Nordic and Scandinavian countries. Yeah, that's the outline of my talk. A little bit about myself. I already did that. Then I will give an introduction about recommended systems, or what is recommendation basically. And as I said, from data point of view, methods point of view, I will talk a little bit about applications and some challenges. Before starting my talk, I would like to ask you a question. May I know your opinion about how many decisions do you think we human beings are making in everyday life by average?
Every second, I think we make a decision.
Just give a number, hundreds, tens, whatever. Just make a guess.
Thousand per day.
Yeah.
15,000.
15,000. Prediction. Actually, research has shown that by average, we're making 35,000 decisions per day. I was actually surprised that there are some people really doing research on that. Interesting. And there are several types of decisions that we make. What to eat, what to watch, what to read, what to listen. These are all different types of decisions we need. Some of them are easy. Some of them are more difficult. Like, for instance, where to invest, what to buy, which house or car to buy. These are more difficult, but still part of the decision-making process. And basically, recommended systems are, let's say, tools or machines that can help us in our decision-making process by helping us to make better decisions, more informed decisions. And how do they do that? They basically check what are our preferences, and based on our preferences, try to predict what we will consume in future and generate recommendation based on that. So they have a lot of benefits for us as customers, users, whatever you call us. And let's say they solve the problem of choice overload, and there are a lot of choices basically, or options. For instance, I have been purchasing a lot from let's say online shops, and some believe that there are like more than millions of let's say options online in online shops, and that's huge. And creating good decision and making good decision is a difficult process. So yeah, as I said, a lot of benefits for us. Choice overload problem, information overload problem can be kind of mitigated by these systems. But is there any benefit also for the business? And the answer is yes. And to basically explain what could be the potential benefits for the business and basically industry involved in this sector, I may show you this, let's say, this graph that basically shows any type of basically any marketplace where you have items sorted from the most popular items to the least popular items. This could be media items like movies, music, whatever, or it could be any other like more tangible like laptops, products, whatever. And y-axis, you can see, is the popularity of those items, basically. And as it's clear, we have a few very popular items, usually referred to as head items. There are a few of them because they are so popular, and a long list of less or unpopular items. And usually they're referred to as long tail because there are many, they're long in the graph, as you can see, and they do not really hit the popular thing. And by its definition, popular items are very visible because they are popular. People know them. People watch popular movies. People listen to popular songs, right? And they have actually high visibility in the market. And long tail items, again, expected they have low visibility. People have less attention to them. People watch, listen, consume them less. And examples, maybe you can consider, for instance, Godfather as a popular item, popular media item, if you want to use media market as or media domain as the application. And there are other movies, for example, maybe Ex Machina, one of the greatest movies, but probably less popular than Godfather, or maybe The Past, one of my favorites, also a great movie, but probably not many of you have watched. Actually, during my talk, I usually ask people, have you watched it? I have rarely seen people watch it, but it's a great movie. And it can be an example of a good movie, but not as popular as the others. And as expected, popular content can be purchased by users by themselves. You don't need to include them in the recommendation, but less popular content, the long tail content can actually be boosted. So basically, the recommender system can learn what are the interesting things for you. If it's popular, maybe it leaves it on you because you will anyway consume it. But if it's unpopular or less popular, like niche product, maybe it can find and recommend to you and increase the, let's say, the quality of the recommendation of those items, so on. So there is benefits because those long tail products will be recommended, will be consumed, will be purchased. So basically, industry business will gain on this. And that increases several factors. For example, it can increase the revenue and profit because they will sell more. They will, let's say, get more of their items purchased and consumed. It will also increase the visit frequency. If you like what is recommended to you, there's a higher chance actually that you visit that shop, you visit that platform more. Increase basket size. You buy something and something else is recommended. Like if you buy them together, it's cheaper. This type of recommendation is referred to as cross-selling. And it increases also loyalty. If you see that the system is really treating you well, with good recommendation personalization experience, you actually become more chance of becoming loyal. There has been a lot of studies by different universities, different institutes, business, and even industry. This is an example that explains that more than 90% of customers in modern life or modern platforms expect to shop brands that recognize, remember, and provide a personalization or recommendation experience. This is one of the latest studies. So yes, good recommender system have benefits for both users and industry. Fantastic. how do we basically explain to them? How do we research them, investigate basically, how do we study these? Well, you can study these systems from very different aspects or point of views. You can study them from data, what data they use, what data they produce, what is their outcome, income, or methods, what are the models, popular models, do they use machine learning or other models, and how about the interface? And in today's talk, I will focus mainly on the data and methods. So yes, data, let's see. How do these systems actually, what kind of data these systems actually use? Well, the recommender system basically use a bunch of likes and dislikes users provide online. And then use them to learn. These are basic user feedback provided to different items, to different movies, to different music, as I said, laptop, mobile, whatever you see. And try to kind of learn these likes, dislikes, stars, whatever different types of feedback, and build some form of models that can represent preference of the people, and based on that, they can generate recommendation. How do we typically model this type of data? Usually we model this data as what is called rating matrix, or let's say preference matrix. And these matrices can be seen differently, but usually you represent users kind of as rows of these data in this matrix basically, and items in the columns. And if the user has rated, provided a rating like 5 out of 5 or 2 out of 5, or likes and dislikes, this is represented as this numerical entry in this matrices. And if the user has not provided any rating, like the one that you see here, the question mark, these are not known, not available, whatever you call it. And so what happens, this type of matrices are usually given to the AI models, to the recommender system that use AI models. AI models kind of learn preferences of the user, try to find some kind of patterns, some commonalities among them. And then based on that, build predictive models. The models that can predict the future ratings, future preference of the users. And based on these future preferences and ratings, they can predict what are these question marks in this kind of rating or preference matrix. So they would know that, for instance, this user is going to like or dislike this item. And that can be a base for their recommendation. Like if it's predicted that the user is going to like it, this is going to be recommended. If the system predicts that the user is going to dislike it, it's going to be avoided from recommendation. But examples of that, then, for instance, as I said, the movies, the past maybe can be fitting to the preference of certain users, and the other movie like Ex Machina or maybe Godfather, it can fit to the preference of the others, and then subsequently recommended to that group. But is it only the likes, dislikes, ratings that can be used by recommender systems? No, they can actually use any type of data. They can use tweets, they can use Google searches, they can use, I don't know, like online purchases, whatever that is done by the users, by the people online, have the potential to be used by AI or AI-enabled recommender system to generate recommendation. And that's basically the interesting part of this is integrated with other. It's true, we have a diverse volume, diverse velocity, and diverse variety of type of data that this type of system can use, but can we categorize? There could be different categorization, but yes, maybe you can categorize this type of data based on whether this is the user data or it's an item data. The user data sometimes usually referred to as preferences. This can be explicit or explicit feedback or implicit or implicit feedback. And item data, usually or sometimes we refer to as content data, can also be subcategorized by high level or low level type of data. High level data, item data is done, it's an example. Low level could be colors, light, explicit user feedback could be ratings, implicit could be reused. But what is explicit? More explanation of them. Basically, these are kind of item evaluation or assessment of the users provided for items that users explicitly report. Like, I love this item. You provide like or dislike, or I love it. I would rate it 10 out of 10 or 5 out of 5. These are usually explicit. They are very informative and informative to the user because if the user said I would rate it 5 out of 5. The system can more or less know that, yes, this is a good item, And I think similar this will be, for instance, recommended. What's the problem? They're very costly. Usually you're not able, or systems are not really able to extract or basically collect this type of data. Not really, they cannot, but it's very costly. Just to give an example, I have been purchasing for maybe more than 15 years, or maybe more actually, things from online shops, different online shops in Norway, outside Norway, and I have never rated in them. And I am doing this research. My research is focused on providing ratings or rating elicitation, what we call it. I have never myself rated anything, but I use a lot the recommended system. I use the local recommendation percentage. How can these systems provide recommendation for a user like me, who rarely or never provide the preferences, but still ask and request for recommendations? That's a million-dollar question. In opposed to explicit feedback, you can also have what is called implicit feedback. These are basically actions performed by the users on items. For instance, watching a video, listening to a song, clicking on something. These are basically potential examples of the implicit feedback. And they are very cheap to collect. Basically, if you build any website, you can get zillions of them every day, every week, every month. You just collect a lot of them if the user allows you, but they're less informative. Why? Give an example. Imagine you have a video streaming platform, or you're working in the platform, and in your platform, the user watches a movie and then drops it, then stops it. Would you consider it as a like or as a dislike? Well, some people will say, if the user just opens and clicks, maybe that's a like. I would say no. Maybe the user just watches the first 10% of the movie and they say, oh, that's a very bad movie, I will not watch it. So that's actually a dislike. So you cannot consider that. Some may say, yeah, but what if you wait and see if the user watched maybe 70% of the movie, and then maybe we can consider it as like. If the user watched less than 7%, so 7% can be the threshold, then we can consider as dislike. Not really. I personally watched a lot of movie until the end, and I was really hating that movie. I felt that it's a horrible movie. So it's very possible that actually the user watches the entire movie or listens to the entire song, and still the user doesn't like it. So that's why these, as I said, this type of data are less informative, because at the end we don't really know if the user likes this item or dislikes, because it's just based on consumption behavior. Do we have other type of data? Yes. For instance, user personality is another type of data. We call it like site information or site user information. What is personality? Is stable characteristics of users, which accounts for individual differences among people. And usually you can see, I took this from another paper, you can see the references. So basically, the personality is a kind of stable behavior or stable characteristics of the user, usually doesn't change. Maybe you love certain things, and like maybe you're extrovert or introvert over years. This is usually doesn't change. And you can, if the user allows you with all this privacy aspect, all these things, if the user says no problem, you can use it to improve the recommendation for me, then actually this can be used to generate recommendation, as in addition to the other types. But how? Well, there have been a lot of studies that showed correlation between users or people's preferences and the personality. This is an example. For instance, I'm an introvert person, maybe I should listen to this type of songs, indie songs, basically, or type of music. I'm not really a big fan, but maybe it can correlate with my personality. Or maybe some extrovert may prefer, I don't know, pop, for instance. But there could be some kind of correlation, weak or strong, between people's personality. And if certain personality is identified, again, if the user provides that information, allows the system to use, maybe the system can find some kind of correlation and use it to generate recommendation. But how this can be done in a system, in a recommended system? Well, we talked about ratings, so you have the ratings. In addition to the ratings, the user could provide some form of questionnaire or something for the personality, and this information can be used in addition to the ratings to generate recommendations. So for instance, if there's a new user, the user has not provided any rating, but the user said, it's fine, you can basically use my personality to generate recommendation for me, then this data can be extended in the rating vector of the user and used to generate recommendation of, let's say, category, the different products for the user. But how to get personality? How do we learn? How the user actually can, if they would like, if they would be willing, how can they provide personality? Well, in psychology, originally there has been several questionnaires with hundreds of questions to identify personality of the people. But then people find a lot of correlation or overlapping between the questions, and they have been reduced to, for instance, 10 questions. This is an example of 10 kind of question or kind of statements to be more accurate. And this can be used to basically provide personality of the user, projected to the model. For instance, this is called Big Five Factor personality trait model, and used for recommendation of the user would be reading to it. There have been also studies that when the user prefers and allows the system, you can actually use the social media data of the users who allows the system and provide such a data to extract personality, to learn personality and use it for recommendation. There has been also been research on that. And in addition to personality, it's possible also to use, for instance, mood and emotions. What are the moods and emotions? It's not my really expertise, but based on what I learned, mood is something that kind of changes. So personality is more stable, mood is less stable. So maybe over weeks, over days, people's mood change, right? So you could be happy now, and maybe because you got the paper accepted, and in a week you're not that happy because you had a car accident or something. And emotions are something that even varies and changes much faster. So now could be you got a very good quality coffee, so you're happy, and then after 3 seconds you got a call that you need to make a big payment, and then you're not that happy after a few minutes. So maybe that could be basis for emotions, and emotions changes over time. And both of this data can also be used to recommend, let's say, to the user. There are different models, there are different kind of theories, how to use them, how to model them. This is one of the famous ones. And based on this kind of model, you can have these kind of emotion, happiness, anger, fear, sadness, disgust, and surprise, plus neutral. So if the user can provide something like, I'm happy today, which restaurant should you go? Or I'm not that happy, play me a good song, then you can also use this information to do a recommendation. We have done some researches also on this direction some years ago. My colleague, let's say, supervised a project where the user were asked, like, are you okay if you provide us some preferences and we use it for this specific project, and then generate a recommendation? They said yes. And then we gave like 2 options, left song and right song. They would listen to these options basically, and then let us use their camera, let's say the laptop camera, if they enabled and allowed us to use, to extract the emotions in their face, basically using facial expression by AI, and basically extracted some kind of preference, the emotion data to identify if the user actually liked the left song or right song without necessarily seeing what the user clicked. And although many people tell me, at the moment, this is not probably looking so difficult because AI has been advancing a lot, but like 10 years ago, that was really some big deal, I would say. And people were asking me how I'm doing. Actually, it was pretty straightforward. So we could have identified differences between people's facial expression when they were listening to different songs. So if the user is now listening to the left song, we see that there are peaks in this feature, which is surprise element. And when the user was listening to the right song, we didn't extract it, we didn't see this, so we can actually use this feature to identify the, let's say, preference of the user. So this could be used to identify preferences and use it to generate song recommendation or movie recommendation also. But something interesting, when we were doing this experiment, I was expecting to see something like this. So people listen to different songs, having different facial expression, happy, sad, and so. But actually, if you have really seen what they look like, this is what you see. So interestingly, I personally haven't seen any differences between their faces when they were listening to different songs. And I was very curious how this experiment would go. I was expecting the result was not really go well, but surprisingly, that AI model was managed, let's say, to kind of accurately identify the emotion based on these kind of poker faces of the listeners. That was the user data. As I said, item data is another category that can be used for recommendation, and you can subcategorize item data into high level and low level. So what's high level? High level is basically what is meaningful, what is semantic. Like when you see them, when the user sees them, there's a meaning. For instance, if you show this page to the user and say, yeah, this is for like presentation Magina, the user, he can easily identify the actors and actresses, also what is the genre of this movie, what is the plot, what is the story of the movie. All of them are basically different type of item data or item content data can be used for recommendation. And as I said, they have meaning. So if you say the genre is sci-fi, the user for sure understand hopefully what is sci-fi and what to expect from this movie. But not all item data has this kind of properties. So there are other types of item data that can also be useful, but they are not as semantic or as commonly understood as the data that I showed you. Examples, colors in the movies. So colors, light, and different visual elements of the movie can be used to convey messages. Example, for instance, it's believed that the blue color can create a kind of loneliness. So if the movie is tuned to blue color, it's possible that they want you to feel kind of, for the actor of the or actresses of the movie, kind of a blue, a loneliness view. And if you have tension, you could probably see more of red, yellow, and this type of color range, indicating of maybe fire, for instance, or any other types. And if you can get this type of information from image or videos, this can also be used as additional data for improving the movie recommendation. We actually had a project on that several years ago, and the idea was, what if we have a user who uploads a movie in one of the popular online platforms? And this actually happens. I was following, let's say, some of the online platforms, some of the people on these online platforms. And in some cases, when they were uploading videos, they forgot to add any data. They forgot to say, oh, this is a movie, it's a romantic movie, it's a genre of romance, it's produced by this person, and blah, blah. So AI can use this data to generate recommendation for me. But they forgot, they just uploaded some of these, let's say, influencers, they forgot, they just uploaded the video, and some of these platforms was not able to actually generate relevant recommendations. So you could see actually a video online, a girl and a boy or something like romance, talking, or whatever, and or even let's say something related to family. And then if you check the recommendation, it was a course on AI in the university, because the AI was not able to collect good information to connect it. After a while, after a few hours, AI could basically track some clips and some information, and then recommendation was improved. But for the first minutes, first hours, you could actually see that this was relevant. So again, the idea of what if we can extract visual information from the movies and use this in this scenario. I don't know if you have heard about this word, but this scenario is called cold start. It's one of the grand challenges of industry. So basically, we wanted to solve the cold start. Cold start have different types. This is the new item cold start. But there's a new item, we don't have any information. Can be recommended to actually to users or not? How did we proceed with this project? So we use some, let's say, AI libraries to analyze the images. So every video can be split into images, because this is basically motion images or motion figures. And so then we can extract some of these images, usually referred to as frame. We can extract them, and they are usually referred to as keyframe. These are most representative images from a movie. Why do we do that? To reduce the cost of analyzing all images, because actually many images are very similar. You don't need to analyze them. We can just pick one of them. That could be a representative one, and then analyze it. And then from that key frame or key image, you can actually extract some visual information representing that image. What are the colors? Is it very colorful? Is it just black and white? And so on. And then using all this and creating vectors, you can actually get an aggregated vector representing a movie. Like, oh, this is a very highly colorful movie or not colorful. It's a high saturation, low saturation, all of this information. And then this was basically used in order to generate recommendation, and it worked very well. I would maybe find a few time to talk about this. But before going to more details, I would also talk about methods in recommended systems. That was basically just data. As I said, recommended system can use any form of AI that you have, or maybe to be more specific, machine learning algorithms. You can use machine learning algorithms, different types, in order to generate, let's say, recommendation, in order to build predictive models. But in general, you can also categorize all of these type of recommendation approaches, recommendation method into two big groups. Those that do personalized recommendations, so different users get recommended different items, and non-personalized, like expert annotated, expert selected, expert pick, and these type of things. Majority of the algorithm, of course, you assume is here. We still have some for the non-person, but usually this is done by human rather than the machines. We can also identify and basically categorize different recommendation algorithms based on if they are using a single method or single heuristic method or combined heuristic. Are you combining several approaches, several methods, or using only one? Are you using a hybrid method or not? These are also possibilities to categorize them. But apart from all many, I don't know, maybe tens, if not hundreds of different recommender algorithms and methods, the most popular ones, I would say, popular approaches are collaborative filtering and content-based filtering. So collaborative filtering, you might have seen this figure, works like it computes similarities. One of the methods of collaborative filtering computes similarities between users, and then checks what has been watched or consumed by a similar user and recommends to the target user those items. So if the user who is similar to me, for instance, watch some sci-fi movies, then probably sci-fi movies will be recommended to me that has been watched or rated by that user. And an example algorithm is SVD or SVD++. Also, these are major algorithms called matrix factorization. And content-based filtering is another big category of the methods. And how do they work? Instead of computing similarities between users, they actually compute similarities between items. So if you work in the movie domain, if you work in the movie platform, then AI would basically compute similarities between two movies. And if me, like as a user or any other user, the target user watched a movie, the other similar movies would be recommended to me. So this is the kind of base for some of these approaches. And a famous algorithm for that is k-nearest neighbor based on the item content, because k-nearest neighbor, it can be used in different forms, but we can also use it to compute similarity between elements. The last part of my talk, I have a few more minutes to talk about some applications and maybe challenges that has been arising lately. So I joke that I did my PhD, I started my PhD in 2010, and at that time, majority of research maybe was focused on the good and positive side of recommendation, personalization. It's great, let's do it. It has benefit for people and benefit for the business. But since I joined Arghandeh University, there has been a rising trend that actually recommendation can also create what we call an undesired effect, which could be negative to the people or to the society. You have seen a lot of these examples. I will talk maybe about two today. Before talking about this, one of the big challenges I already introduced it to you, cold start. So if you are searching for a research topic that can still be, I would say maybe hot still in the research community, we can work on cold start. There are different types of cold start, new user cold start and a new user registered to the system, and we have no information about this person, and we want to make recommendation. Or new item problem, when a new item is added to the catalog, like a movie is uploaded to one of these streaming platforms, we have no information about this item. How can we recommend this item to this person? I already said you can use this approach to generate cold start recommendation. And we have done a very cool study on this, basically analyzing the movies that are new to the system, new to the user, and generate a recommendation based on that. We collaborated with industry. How did we do that? So this is, imagine you have 3 movies, like these are just examples. One of them is more black and white, the others are very colorful, one of them with high saturation and contrast, the other with low saturation. And we know that user 1 likes this movie, and user 2 likes this movie, and user 3 likes this movie. Then we recommended movies in this way. So this user will get this type of recommendation, and this user will get this type of recommendation, and this user will get that type of recommendation, the different colors. There's actually a live demo, so if you have time, you can go to this URL. Maybe I have time, I can show you also today. But so basically what happens if you click on each of these, let's say, posters, the entire page changes, as you can see, with the colors of that poster. And the next recommendation would be based on this, let's say, type of color, this type of specific visual features. And this was in collaboration with TV2. In addition to that, we also did some interesting topic on one of the undesired effects or big challenges in the recommendation system. It's referred to as popularity bias. So what's popularity bias? I already introduced this graph. It's a graph of popularity of like different items, like different movies, different whatever products. And as I said, there are a few very popular head items and many unpopular or less popular niche products, referred to as long tail. I already said that popular items have high visibility and unpopular items have low visibility. And examples, already talked about this, these could be potential examples. And I said that we expect that the recommended systems basically boost this part of the graph, basically finding what is interesting to the user and recommending it from the less popular. Why not from popular? Because anyway they're popular, anywhere I will find it and I will watch it. But our analysis interestingly showed that it's nearly the opposite. So strangely, we realized that many recommend the system, if not all, actually mainly recommend popular. And this is really strange. This is really strange happening. I mean, strange from the fact that from the things that I would have expected the opposite, and I did not see it. And that's why actually all the time the highly popular content get even more popular, and items that have low visibility and unpopular over time through recommendation, they get even less and less popular. What does it mean? If you are a movie maker, if you are a small company, if you are a restaurant, if you are any basic type of business, and by chance, if you do not end up with this part of the market, it's possible that you'll not see, if we either never seen through recommendation or rarely seen through recommendation, and that's a problem. So what are the potential approaches? There are different methods that are proposed so far by community to mitigate and potentially solve this problem. One of the methods is called re-ranking. So it takes the output of a recommended system and then tries to substitute the very, very popular content with something less popular content, hoping that the one that is less popular and relevant could be more interesting to the user than just popular content, just popular items. And one of the popular techniques is basically a technique that splits the users into 3 groups. The users who love to see popular content, the users who love to see less popular content, and the users in the middle. The users who are interested, like maybe me, to see mostly the popular content would be recommended more of the popular content. The users who would like to see less niche content, they will see niche content. We have been collaborating with some industry partners of our project, our Center in the Futures, and we have done what is called A/B testing. So some of the users on the platform has received a recommendation from, for instance, Collaborative Italy, and some of them received from an algorithm that would mitigate the popularity of the recommendation through a certain algorithm called calibration. And the result was interesting. We have seen that the user group that received recommendation less popular actually watched more and actually have been exposed to more recommendation. What does this really mean? First of all, if you measure click-through rate, you know that industry loves click-through rate. You would get higher click-through rate if you manage to reduce a little bit of popularity of your recommendation. So people actually love to see less popular and still interesting content. This was not really what we expected. Usually we expected people love to see something like maybe popular, more relevant to them based on popularity, also things like this. And if you reduce popularity, maybe accuracy drops a bit. This is what previous studies have shown, and we were expecting this. It's a known, what we call a trade-off. But actually, we have seen the opposite. Click-through rate has increased, and people manage to find, according to this metric, find faster the movies that they are interested to watch. And that was very interesting and phenomenal result. All of these have been summarized. Many people ask me if you want to recommend maybe one paper relevant to your research, what would that be? I would suggest this. This was a collaboration with 14 different co-authors from largest industry, movie industry in Norway, talking about responsibility recommendation. It's called responsible media recommendation. We're welcome to have a look. And in addition to that, if you want to have some more ideas of how these approaches have been applied, especially in the social media, in the social recommender systems based on social data, you can read one of our recent publications, social data analytics. With that, I will thank you very much, and I can take questions.